This is section 2.4. Suppose we have a universal set 1, 2, 3, 4, 5, 6, 7, 8, and 9, and we have sets A, B, and C. What I want to know is A intersect B union C complement. Okay, so when you're doing these, what I want you to do is start with the parentheses first. So inside the parentheses, I need B union C complement. So before I can do B union C complement, I have to find C complement. Okay, so starting on the inside, working your way out. So the very first thing you need, C complement. If C is 2, 3, 4, 6, and 7, then C complement, 2 is in C, 3, 4, 6, and 7 are in C. So the complement would be anything that's left over, 1, 5, 8, and 9. 8 and 9. Okay, so that's C complement. From here, I need to find B union C complement. So that set that I just found, 1, 5, 8, and 9, and I want to find the union of that with B. So here's B, and here's C complement. So when I take B union C complement, remember the union means put the two sets together. So B has 1, and C complement also has 1, but we only need to write one of them. B has 2, so I need that. 3, 5, 6, 8, and 9. Okay, so now we have B union C complement. Now, finally, what we need is A intersect that set that we just found. So we look at our A, which is this. Remember, the intersection is what do they have in common? What's the overlap? So A intersect B union C complement. Okay, what do they have in common? Well, they both have a 1. They both have a 2. They both have 3. And they don't have 4, but they do both have 5. So that would be your final answer. 1, 2, 3, and 5. For this slide, I want you to take a look at it. I want you to read through it, but I'm not going to make you write it down. It's an awful lot of writing. So let's first look at the region in dark blue. When they say dark blue, they're talking about that region right there. So what this is right here, this region in the middle, that's the intersection of all 3 sets. That's symbolized by A intersect B intersect C. If I look at, I don't know, this area right here, that's the intersection of A and B. So read through it, but don't stress about this too much. I'm not going to make you write this down. So use the Venn diagram to find set A. So set A is anything that's in this circle right here. So set A, we have 11, we've got 3, we've got 12, and they do not have to be in order, doesn't matter what order we put them in, we've got 5, 7, and 6. So that's set A. A union B. A union B means take everything that's in A, all of this, and everything that's in B, so all of this. So A union B, I'm going to put the two sets together. So everything that's in A, which is 11, 3, 12, 5, 7, 6, 5, 7, 6, and everything that's in B. So we also need 1, 2, 10, and 9. So A union B. B intersect C. That's where B and C overlap. What's in both B and C at the same time? So that would be this part right here, the overlap of B and C. So we have 5, 7, and 9. C complement. Remember, the complement is anything that's outside of the set. So we need the complement of C, so anything that's outside of C. So we're not going to include this region right here. So anything that's outside of that region. I didn't say this before, but just as a reminder, these Roman numerals just label the regions. They're not actually part of the set. So we have 11, 3, we've got 12, 1, 2, and 10. Now for A intersect B intersect C, that's the overlap of everything. And in the overlap, we have 5 and 7. Use a Venn diagram to prove that A intersect B complement is the same as A complement union B complement. So what we're going to do is we're going to draw a Venn diagram for this one, draw a Venn diagram for this one, and show that they're the same thing. So what we need to do is a Venn diagram for A intersect B complement. So we're going to have a region, and we have A and B. So we're going to label our regions 1, 2, 3, and 4. So A intersect B is where they overlap. That would be region 2. And we need the complement of that, so that's anything outside of region 2, which is regions 1, 3, and 4. Now for the other one. Again, we have region 1, 2, 3, and 4. So we need A complement, that's anything outside A, so that would be 4 and 3. And we need B complement, which is 1 and 4. So A complement, B complement. So the union of those, A complement union B complement, remember when we take the union, put both sets together, so we have regions 1, 3, and 4. And since the regions are the same for both, that means these two are equal to each other. Since they're represented by the same regions, the result proves that they are equal. De Morgan's laws. You're going to want to write this down. You're going to want to write this down, and you're going to want to memorize these two facts. So if I have an intersection and a complement, so the intersection's on the inside, to distribute the complement, if you will, the sign has to flip upside down. That becomes a union. Same thing applies with the union. If I take the union with the complement and get rid of the parentheses, that union becomes an intersection. So you're going to want to remember De Morgan's laws. Homework 4 through 64 and 8 through 88.